Alright, so what we're going to be talking about right now is epidemiology. So what we're looking at in epidemiology is kind of the prevalence or how disease spread. So right here what I have is a little chart. Don't really get too caught up in the symbols. So for interest's sake, they're all Greek, if you were wondering. So what do we want to look at when we're doing epidemiology studies? Okay, so we want to look at the prevalence or the spread of disease, number of incidents, and how that is caused. We want to look at the prevalence and incidence of disease in populations. So these can be small populations, like say a classroom. It could be something like a county, a state, a country, or even globally. So some things that we might think of a global pandemic. So what a pandemic would be is something that a lot of people are getting affected by this in a very short amount of time, and it spreads wildly throughout the globe. So a good example of this might be the flu in 1912. So it killed an astronomical amount of people back in 1912, and this led to some of future design in flu vaccines, for example. So Spanish flu is a really good example to look of when we have a pandemic. Other things like maybe an epidemic might be, again, we could look at, say, like swine flu, for example, if it's regional, or any kind of disease that it is spreading quickly in an area. We have endemics, which is a pretty standard populations getting affected. It's not, very quick over time. We have sporadic infection, which is sporadic, it's random. So these are some of the main classes of definition when we're talking about disease. So right here we have epidemiological table that we have incidents are marked in positive or minus. So we have these individuals. Okay, they go through a series of exchanging fluids with each other, or they're shaking hands. So right here in blue is handshake number 1. In black is handshake number 2. And you'll be able to see as you increase the number of times people are shaking hands, the more you increase points of contact, the higher the population incidence is going to be for your infectious disease. So right here, when we're trying to figure out who the original pair who shook handshakes were sick. So if I'm looking at this table, the first thing I might do is say, okay, all of this right here is negative. So what I would do right off the bat, strike through this. It's negative. I don't have to worry about any of these in looking through and trying to pinpoint my original incident. So what I do is I have the beta and alpha and epsilon. So anywhere I have those, I can cross them out. So I know here, I know here. Let's see, there's an alpha right here. There is an epsilon down here, one down there. And that looks like all of them for right now. Oh, there's another thing right there. Okay? So now, I go to my next negative. And now I can see that my Omicron right here is in a negative group. So I'm going to mark this up, and anywhere there's Omicron, I'll scratch that out. Out, out. Alright? So then let's go to my next negative. So that's this row here. So anywhere where I have a a K, so kappa, a mu, or a lambda, I'm going to cross out. So kappa, lambda, mu. Okay. So now I go down to my next one and I see that it's now my new, which looks like an N here. So then I'm going to find anywhere that I have, so there's that. So now I can see that all of these are done. So all of those are out, all of those are out. So I've now limited all my negative people. So now what I'm interested in is I have a plus row right here. Mu and kappa we already marked as they didn't have it originally. So I have delta right here, which is a positive. Then here I have another positive, which is gamma right here, and delta. And then another positive, which is delta and gamma, and another positive, which has gamma. So when looking at this, we can make an assertion that this is later on in the number of times people shake hands. So we can't say that this was the original. So we want to look at the original pair. So your original column here and your first handshake. So that means that right here, so between our gamma delta and our delta gamma was the original intermixing. So I have delta and gamma was the original. So delta, gamma are the original incident. So now what we'll talk about real quick is how you actually calculate incidence in a population. Now what we're going to be looking at is the prevalence of disease. So this is how much it's affected a certain population over its total lifespan. So from the first incident to all the way up to the final incident. So this is, for example, how many people caught the cold in 2017, for example. Whereas incidence would be new cases. So what we're going to look at in this example is we're going to use our original chart that we had for the prevalence. So we're going to say our total population is 10. So if we go back, you can see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 rows, we have 10 individuals. Okay? So for my prevalence, I'm just going to use this chart that we have. So my prevalence, the total number of cases, so I have, let's see, 1, 2, 3, 4. So I have 4 cases per 10 people. Okay? And we want this to be in a percentage. So times 100. So this means that my prevalence of disease in a population is 40%. So depending on how your book says it, so this is 40% of the population. Okay? So depending on how your book says it, it might be, for example, I have 40,000 people out of 100,000 people is my prevalence of disease. So it just depends on how the question is asking you to answer it. Okay? But usually these are thought of as percentages of population. So now for my incidence, I'm going to say my population population is equal to 100 people. And I'm going to say that this chart that we just did is for the new cases of my disease. So, new cases of, let's call it micro-nilla, or class. We have school. New cases of feelings. So, our new cases of feelings that recently have occurred, we have 4 new cases. So, we have 4 cases out of 100 people. So, again, if we look at this as a percentage, we multiply times 100, and this would give us 4% incidence in the population. Or, you could write this, depending on how you answer, 4,000 people out of 100,000. Incidence equals out of 400 people. So this is going to be what we're looking at in epidemiology and studying. The really fun lab that we do for this is we have little droppers, and you exchange fluids, and then after you exchange fluids, when everyone's finished, you have marker in every fluid. You put in a droplet, and if your fluid has a pH change, the pH indicator will turn it pink or whatever color, and then that way you could use that to see how quickly disease spreads. So this is really cool, looking at different things, for example, like college campuses, prevalence of disease, certain diseases, incidence of disease that might happen in a year. So these are really neat tools that we use to track and control disease.